welcome to my presentation on PX4 on the S32K Automotive ASIL Functional Safety Ready hardware platform. So let me just first introduce myself. I'm Peter van der Perk, working for NXP Semiconductors Eindhoven, Netherlands. And primarily I'm working for the ADAC-Corsa Beyond Visual Line Safety Subsidy Project, which is a European subsidy project working for ruling for BVLOS drones in Europe and think about the safe architecture for that. And together with multiple sites, multinational team, our mobile robotics team, NXP, we're trying to create reference platforms, such as vehicle units, CAN nodes, battery management systems, all related with NXP technology and subsystems for drones. And our systems can either run PX4 or NODEX or both of them. So we try to integrate it with the whole PX4 architecture. And next to it also we use this hardware for the hover games, NXP hover games kit, which is the basic drone kit, and students can participate and learn how to use a drone, build their own drone, and use PX4 and NXP hardware. So let me just give a very quick introduction of UAV and safety certification. So I think mostly right now in the current state there's no real optimized certification standard for drones. So what you see in Europe, you have this U-Space initiative, and they refer to the standard functional safety IEC 61508 standard. What you see is are these automotive optimized safety certifications, but also the avionics one. And both have their pros and cons. I think if you look at complexity, avionics is striking that hard. Also, it doesn't cover the autonomy use case, and it's just expensive and also following that. And automotive, the nice part is you have the ISO 262 standard, which is a pretty young standard, and also thinks about ADAS and highly automated driving as well, so which kind of follows the BVLOS use case. So we're kind of looking at reusing the technology that's already certified for the other parts into a drone, and can we leverage that? So just a quick introduction about ASIL or safety integrity level. So that's the standard functional safety clauses and how that maps. So right now we're talking mostly about automotive safety level, safety integrity level, because we're talking about our automotive products, but they're kind of closely mapped to different standards. So right now I'm talking about ASIL, which will be closely related to SIL 3 for the standard functional safety part, and for aviation it's close to DEL B. Okay, so let me introduce the Merkenhub platform. So this is a S32K3 platform, which is a reference platform to play around, and we kind of have three use cases for. So we have this vehicle management unit, so the PX4 flight control would be an example for that. Also a CAN gateway, so we want to step away from the point-to-point connections with sensors and try to make more a bus topology for. But just like cars, you probably have to have some gateways. You maybe want to sophisticate and convert CAN to Ethernet. Also for drones, motor controllers, you don't want to have a bus topology for the drone, for the motors, because if one motor fails, your bus might fail. So you can also use this as a hub and then turn one signal into multiple CAN signals and have multiple signals for that. And we're also experimenting with motor control, where since this is a MultiCore platform, it can be either a lockstep or MultiCore system, can we have motor control doing real-time ESC control and have a high-level stack for controlling that, either CAN, DDS, some IP, some high-level standard to control that, which would be ease of use for end user. Just think about the motor control of that. So this is just a quick block diagram, what the board. So we pretty much have the S32K3, we have lots of CAN on it, we have lots of UART on it. But these are kind of the basic ingredients we brought out, and this is more the idea, okay, let's run PX4 on that, and what are the ingredients needed for that? So we have SPIs, so we can log to SD cards, have the PX4 logging on that. Nowadays, Ethereum is something also with internet logging. You can use Ethernet, it's way better than using a SD card, I guess. Some UARTs for your GNSS, RC, PWM for motor control, and then we have a IMU connector, which is pretty much the same one Autopilot uses for the V5X. So we can reuse the same sensors over there. And then the next part would be think about Ethernet and CAN for also sensor networks, and try to step away from I2C SPI, all that part. Yeah, quick introduction. So S32K, it's quite a big family. There are multiple parts in there. So right now, I just want to say for me, the focus is on the lockstep part. So that has this ASIL certification level. So this is mostly focused on safety. Then we also have some extra features to do that. So we have lockstep, but we also have this concept which is called this fault collection control unit. So this chip has multiple functionalities. We have CRC checks, we have health checks of subcomponents, and based on that we can collect these faults and then decide what to do with that. Think about resetting the system, resetting applications. For now, we just want to run PX4 and NX on it, and then we want to take a step further and try to leverage that and see what would be the base ingredients to make things safer. Next to that, also this is more how the chip is designed. We also have to use a safety basis chip, so your DC-DC converter that acts as an external watchdog. So the nice part about this is a quite advanced safety SBC that also does challenge response to the micro. And if the micro doesn't respond in time, or there's a fault, then probably is a hardware fault, and we can also have a reset strategy or a fill silence strategy, which is typically done in automotive, because otherwise things get way too complex. You have way too many states where you can branch into. Although for drones it's a complex state, because for a car sometimes shutting down is an option, but for drones it would mean either deploying a parachute or having another backup plan. But for now it's kind of the basis we want to have. So yeah, the focus is that we want to bring in this platform in PX4 and then have the baseline idea of PX4 running. We can experiment with that and utilize these hardware features. I'm talking about functional safety, but there's kind of this disclaimer is that hardware can be functional safe, but then also the software and applications on top of that also have to be like that. So this is more like a demonstration platform. If you want to go the full correct way, you have to have a safety certified RTOS. One might have to be able to certify PX4. So regulation-wise, I think we're still far, far away. But I think it's nice to have a basis and see what components we want to bring in for that. Yeah, so this is the flight test. So we have an internal port of PX4 and NUTX running. Oh, sound even. So actually, hopefully next month we can upstream the NUTX support. So it's just all open source software where you can use for this platform. And based on that, we hope to upgrade the NUTX version also on PX4 to synchronize on that and also get our PX4 part in there. Yeah, still lots of tuning has to be done. Our IMU is not stabilized here, so it's mostly about proof of concept and closing the whole feedback loop. It's not perfect, but it's nice that we already can fly and test with it. So this is a short introduction of the concept we're working on for the ALEC project, the Beyond Visual Line of project. So right now we're trying to think about some kind of distributed architecture that would work for such a system. So typically you have your flight control, flight management domain, so that would be your PIX-Hawk. And we're experimenting with the idea to put this side by side, that run a PX4 version, maybe a stripped version, and try to decouple all the components over the network. And the nice part about it is that you have two devices that control a motor, for instance. So if your typical flight controller fails, or our safety monitor can check if the tolerance is okay, or this command doesn't make sense, or the other system gets resetted, we could potentially take over, stabilize the drone, and do a safe landing to some degree. At least we want to avoid the worst case scenario, which is just having a drone falling out of the sky. Yeah, so that's the isolated domain concept we have, and then also we want to introduce this concept of networking. And then the next step is what we have as a trend is that we have multi-core systems, is that we can maybe then also leverage and bring it together on a single chip. And there are lots of features to have freedom from interference from the auto core, from other parts. And then you still have a cost-effective solution where you have your flight management domain, and you have your stripped-down version. You have just a single system to do that. And then also we're thinking about the, I would say, more fully autonomous systems where you put an application processor next to it, and you put even internet next to it. And then you have like a complete safety concept of the network. So let's say we have the follow me demo or detect avoidance. We can run on that. We can think about that would be failing, so we can always fall back on just the base principles of flying the drone, but still leverage ROS2, autonomy there, perception stacks of such a concept. Yeah, so timeline. So pretty much next week, 3 weeks, we want to upstream the NUDX PX4 NUDX port to run the operating system, and then yeah, we already have the internal demo. I think we have to rebase, and hopefully nothing breaks, and then we can have this also PX4 support on it. And then in Q3, so in a couple of months, we also want to launch the sale of this board, so people can also experiment with that. Yeah, conclusion. So it's a nice about PX4. If we take a new board, we make sure that we can run the operating system. We have the abstraction layer, and you tinker around with getting all the inputs in there. That you can just already fly a drone. Typically, it's way more work to do that. So PX4 Autopilot is a great platform for just experimenting and think about these features. And I think with our S32K platform, we have now new exciting ideas about putting in lockstep, ECC, more advanced features compared to more consumer electronics that has been used right now. Yeah, so you can check out the NXP website for the S32K, and yeah, if there are any questions, feel free to ask.
So, if you have lockstep, got 2 M7s, right?
Yes.
Can you run them out of lockstep on
Not during runtime.
They're hard-coded in lockstep.
So I think you have to do a full reset of the system. You have to do a full reconfiguration. So it's flexible for, I would say, development, but it's not the main goal to do that during runtime. The lockstep functionality is actually quite advanced. So there is like a separate tick there. It does some kind of fallback. So there are many things to try to save it. And if it then completely fails, then you go into your reset mode.
Okay. Could you go back one picture?
Yeah.
Yeah, actually 2. So the automotive switch, is that 100 megabit or is it gigabit?
So that's 100 meg base T1. So that's the 2-wire.
Yeah, it's the automotive Ethernet.
Yes.
Yeah. Okay. Okay. Is there any plans to upgrade that to gigabit for radar and camera interfaces in the future? Or?
Yeah. So the new standard, I think, is just 1,000 base T1. That's all in the roadmap.
Okay. All right. The kit that you release, is it going to be an option for Hover Games drone, or are you going to have a different development kit?
So this is separate from Hover Games. This is mostly to have a K3 platform. So
yeah, I know it's because that's a different IMU. But can you run it on your Hover Games? Is that how you're developing, or is it different platform?
Yeah, so I'm just leveraging the Hover Games platform. So that's just the internal.
So we could just swap out our K66s, throw one of these on there. When is the dev kit going to become available? Is there going to be a dev kit that's sold with it, or how's it going to sell?
Yeah, so it's going to be sold as a kit with a debugger, and around Q3 somewhere. Then.
Around Q3. Okay.
Yeah.
Oh, good.
Okay, thanks.